In today's experiment, you are going to determine the molar volume of hydrogen, which is 22.4 liters per mole. I hope your instructor has informed you that any gas has a molar volume of 22.4 at STP conditions, whether it's hydrogen, oxygen, helium, whatever. But it has to be at STP conditions. Now, the 22.4 liters is approximately the volume of 3 basketballs. You're going to take the same data and you're going to determine the value of R is using the ideal gas law. PV equals nRT. And of course, you know the value of R is 0.08257. Notice that's a very small number. And if you hit that, that means your techniques are very good. But you're going to determine the value of R and PV equals nRT. And of course, when you use PV equals nRT, you're going to have pressure, you're going to have volume, you're going to have moles and temperature to get R. Then you're going to take the same data and you're going to determine the molar mass of magnesium metal, which should be 24.31 grams per mole. So you're going to do those 3 calculations from one set of data. So we'll run the experiment once, get the data, and then you just have to manipulate it to make those computations. So again, just one experiment, 3 pieces of data, 3 very important pieces of data: the molar volume of a gas, the value of R, and the molar mass of magnesium. In this experiment, you'll be using a eudiometer. And if you think of a eudiometer as sort of a test tube, it's got a rounded end, and with calibrations on it. So sort of think of it as an educated barrette, because you've got the value numbers on here, up to 50, of course. They come in different sizes, but we're going to use 50, and so forth. So we're going to use this. So this is what our setup is going to look like. So we will have a beaker down here. This is the eudiometer. We will use a barrette clamp to hold it in place. And what we're going to do is we're going to weigh out some cleaned magnesium ribbon. So I've cleaned it already and weighed it out and tied it to the string. Okay. Now the reason we clean it is because on the surface there's magnesium oxide and magnesium nitride, and those add weight to the magnesium. So I took a piece of steel wool and cleaned it, then I weighed it. And I'll put that data in the data table. So I've weighed out my magnesium, I tied a string to it, and if you notice in the bottom of the picture, your magnesium is at the bottom on the string, and then there's a little cotton ball. Now the reason, the reason for the string is because the magnesium is so light, when you put it in water, it would go right to the top of your eudiometer and stay there, so you wouldn't get a reaction. The cotton ball functions merely as to hold the string in place. Neither of them are needed, but they're just functional in this experiment. So the cotton ball just holds your string in place. The string holds your magnesium in place. Now what we will do is put about 5 milliliters in the, turn this upside down, put about 5 milliliters of HCl in there, 6 molar, and then we'll top it up with distilled water. So if you notice, I've got my magnesium ribbon in, well, maybe 5 centimeters. Now I'm going to top this up with water, and I'll put a bead at the top. Now I'll take a small piece of cotton, I'll moisten it, and then I will just push that in there, trying not to get an air bulb in there because I don't want air in there. And notice now everything's ready. So my eudiometer has the acid at the bottom. As I move up, I've got my magnesium. Again, the cotton is just to hold the string, and the string is just to hold the magnesium. Neither serve any other function in there. If you notice, I have a thermometer in my thing because I'm going to take the temperature of the water and assume, because my hydrogen bubble through it, it is the same temperature as the water. So I will invert this, and you probably cannot see it, but because the acid is more dense, it is slowly going down in towards the bottom. Once it reaches the magnesium, the reaction should start producing hydrogen and another product which you should know, since it's magnesium and hydrochloric, magnesium chloride. I'll see if I can get it if you can see anything like that. You can sort of, hopefully you can see some movement there, other than me. So now as the acid gets towards the bottom, you should start seeing hydrogen evolving, and as the acid comes in contact with it. And this experiment will run until the magnesium has totally dissolved, and we will get a volume of hydrogen in our eudiometer. Again, the string is just holding the magnesium, so it's at the bottom of the eudiometer. Otherwise, it would have floated up to the top and put an end to your experiment. The cotton, again, is just holding the string in place. No function at all. And if you happen to notice, what color is hydrogen gas? Hopefully you said colorless. You notice the generation of hydrogen increases as the more concentrated acid gets on top of that magnesium metal. Eventually the reaction, though, will come to a halt,